Here we will look at adding fractions using area models. This standard builds on the work students did in 4th grade, where they added fractions with like denominators. It also requires students to apply what they learned about finding equivalent fractions, since their work will involve fractions with unlike denominators using related fractions. Related fractions are like those that you see here, 2/3 and 5/6, in which one denominator is a multiple of the other. Students in 5th grade are also expected to use benchmark fractions to assess the reasonableness of their answers, and they should have ample experiences using models to build understanding and to allow them to use reasonableness to find a common denominator prior to using the algorithm. So here we'll look at using area models to add 2/3 and 5/6. Before we begin, we'll estimate. This way, when we have our final answer, we can help make sure that it is reasonable. When we first look at 2/3, we just need to think about what benchmark number that's close to. Is it close to 0, 1/2, or 1/2? And 2/3 we know is close to 1/2. I know that when a fraction's numerator is half of the denominator, then that fraction is equivalent to 1/2. And I know that 2 is close to half of 3, so that means that this fraction is close to 1/2. 5/6, I know that fraction is close to 1/2. It is just 1/6 away from being 1/2, whereas it's 2/6 away from 1/2. This would mean our estimated answer would be 1 and 1/2. Now let's go ahead and look at how we can use area models to solve. We'll begin by representing both of these fractions. So we'll draw an area model here so we can show 2/3. We want to split them into 3 equal parts, as equal as we can by hand. So let's see here, I'll shade in 2/3. And then we can label this. And I know that I'm going to add to that 5/6. And I will split this into 6 equal parts so that I can model the 5/6. Go ahead and shade in 5/6. So there's 2, 3, 4, 5. And so now we have our 2/3 and our 5/6. However, we know that we cannot add these two fractions together unless they have the same denominator. And so when I'm looking at my model for 2/3, I can see that this model could be split into 6 equal parts. So if I just divided each section here that we have with our thirds, if I split each one in half, I would now have a model that is split into 6 equal parts, or sixths, and I could see how many sixths 2/3 is equivalent to. So I'm going to do that now. If I just draw a line like this, you'll see that this model is now split into 6 equal parts, and there are 1, 2, 3, 4 sixths shaded in. That tells me that 2/3 is equivalent to 4 sixths. So now we're going to be looking at adding 4/6 plus 5/6. So we can draw area models to show that. I can already tell that our answer is going to be more than 1/2, since I have more than 1/6 to add to the 5/6. So I'm going to go ahead and show 2 area models here. And I will split both of these in sixths. And now we can go ahead and shade in. So let's go ahead and first shade in our 2/3, which we saw is equivalent to 4 sixths. So we'll shade in 1, 2, 3, 4. So we have 4 sixths shaded in. And now we know we have 5/6 to add to that. So 1, 2, 3, 4, 5. And we can see here that when we've added the 4/6 plus the 5/6, what we have shaded in all together, we have 6 sixths at the top and then 3 more 6. So we could write this as 9 sixths. That would be the improper fraction. We can also tell from how we've modeled this that this is equivalent to 1/2. This is equivalent to 1 and 3/6 because there's 1 whole shaded in and 3 additional sixths. Students may also realize just from their knowledge of equivalent fractions, benchmark fractions, even from just looking at the model here, that this is also equivalent to 1 and 1/2. And so from this we can see that 2/3 plus 5/6 is equivalent to 9/6. So the sum would be 9/6. That can also be written as 1 and 3/6. And we know that's also equivalent to 1 and 1/2. And when we compare our actual answer to our estimated answer, we can tell that our actual answer is very reasonable based upon our estimate, since they're the same thing. We got 1 and 3/6 or 1 and 1/2 as our sum, and we had estimated that the answer would be around 1 and 1/2. And so this is how we can add fractions using area models.